Okay, welcome back to Mr. G's lab. And so today we're going to deal with covalent bonds. And so what are covalent bonds? Well, covalent bonds are uh, basically a sharing of electrons. In covalent bonding, the atoms want to become stable. They want to become a noble gas. Helium, neon, argon, krypton, etc. Um, and they don't lose or gain electrons, they share the electron. And, excuse me, and when the electrons are shared, that pair, those two electrons that are shared, are called a bonding pair. And chlorine forms a covalent bond with itself. And so when that happens, the chlorine gains one electron to share to, so each of these two electrons are going to share with each other. And so basically they're going to come together and form an octet on both sides. The octet rule basically means that there are 8 electrons, 4 orbitals. Remember when we did the Lewis dot structures, that each pair represented one orbital, and each orbital, you're going to have a maximum of 4 orbitals in a shell. So, and the octet is shared by this electron pair in the middle, and this is called the bonding pair. It's a single bonding pair. You can have double bonding pairs, you can have triple bonding pairs. Uh, and a lot of times we're going to basically, instead of putting the 2 dots, we're going to put a dash, because two dots, a single bond, is represented as a dash. So this is the chlorine molecule. Oxygen is a diatomic molecule, and if you remember, diatomic molecules are atoms that bond with themselves. Examples would be bromine, iodine, nitrogen, chlorine, oxygen, hydrogen, and fluorine. And in this case, oxygen is a diatomic molecule, and it's going to have 2 atoms bonding, and you're going to have 2 of these coming to the center and bonding together, and they are going to share the electrons again. And because of those 2 shared pairs in the center, in combination with each, you're going to have a total of 8 electrons around each oxygen atom, giving you a full octet, basically making the electrons stable. When we have, so oxygen has 2 bonding pairs, that makes it a double bond. And remember, the two electrons in one bond is represented by a dash. In this case, you're going to have 2 dashes. So this is the oxygen molecule. You're going to have O2, and that's it for that. Hold on a second. So I had to get to the handy dandy periodic table, and the valence electrons that we refer to are in groups 1, 2, and again, sorry about that, 1, and then we also have 2, 2. So areas 1 and groups 1 and 2 are highlighted, and that would have valence electrons of 1 for group 1 and 2 for group 2. Group 3 would be for group, I'm sorry, three valence electrons would be for group 13, and 4 valence electrons for group 14, 5 valence electrons for group 15, 6 valence electrons 17, all the way up to group 18. And the valence electrons are representative of each group, which is where we're getting the electrons to put around the element for the Lewis dot structure. And now let's head on over to our worksheet. So for this worksheet, I want you to work on creating Lewis dot structures. So for number 3, we would have Lewis dot structures. For oxygen, we would have oxygen, and you have 6 valence electrons, 1, 2, 3, 4, and then we're going to double bond it. 1, 2, and then another then we're going to double bond it, and yeah, so here we have our octet rule satisfied, and here we have our octet rule satisfied. So it is a double bond because you're sharing these 4 electrons in two separate bonds. And then we also have nitrogen. Nitrogen has 5 electrons. So if we just put 2 on each end, nitrogen, nitrogen over here, and we move all 3. Nitrogen has 5 valence electrons. I'll let you look. 5 valence electrons above group 15, and yeah, so we put 1 pair on each side, so those two electrons are satisfied, but now you have 3 electrons that are looking to bond with something. And so we have a total of 6 electrons in the center, and we have 2 electrons on the outsides. So you have 6 plus 2 more, that yields a triple bond, 1, 2, and 3. So triple bond, and this one is the tough one. So boron, you have, let's look. Boron has 3 valence electrons. So it's going to have 1, 2, and 3. And then fluorine has 7 valence electrons. Group 17, second to last column. Fluorine has 7 valence electrons. And so we'll put 1, 2, 3, 4, 5, and 6. Oops. And then 1 here. So if 2 of these combine together, that gives me B, and that'll give me 1 and 2, right? Okay. So that's these 2 right here combining together. And then we have 1 extra electron. Well, fluorine needs an electron. And so fluorine needs an electron. It was 1, 2, 3, 4, 5, 6. This is actually an ionic compound. And you have 1 extra electron, so we're going to put that from there. And then we're going to have the fluorine. And so fluorine's octet rule is satisfied, and boron's duet rule is satisfied. But boron, because why? Because the boron has given up its electron to the fluorine. And it is a single bond. Or I would be fine if you wrote ionic bond. Okay, and so that's how you're supposed to do it. I've done the most difficult ones, so you attempt the other ones. And then here we're calcium. So you're going to look at ionic bonds, which is a metal and a nonmetal, a covalent bond, which is a nonmetal and a nonmetal, or both. It can be a compound containing both a metal and a polyatomic ion. So, for example, calcium is a metal and chlorine is a nonmetal, so that's an ionic bond. Carbon is a nonmetal, oxygen is a nonmetal, that is a covalent bond. Valent. Okay, and that's how I want you to complete the rest of this sheet. So if you need some help, you know where I'm at. You have my email, you have my cell phone number. For those of you who are not in my class, feel free to leave a comment below and I'll get to you usually within a day or so. You all have a wonderful day and a wonderful weekend, and we'll talk to you soon. Bye.